In the late 19th and early 20th centuries, trains powered by steam engines were at the forefront of industrial progress. However, as cities grew larger and more populated, the limitations of steam technology became glaringly obvious. Urban areas suffered from smoke-filled skies, transportation inefficiencies, and growing safety concerns. The electrification of trains emerged as a groundbreaking solution, not just for railways but for urban transportation as a whole. This story of electrification is one of engineering ingenuity, societal demands, and transformative outcomes. Steam trains had been a symbol of progress since the early 19th century, but by the late 1800s, their drawbacks were hard to ignore. Coal-powered steam engines blanketed cities in dense smoke, creating severe air pollution. In London, one of the world's busiest rail hubs, trains at stations like Euston and Waterloo produced so much soot that respiratory issues among urban residents became commonplace. With over 1,000 steam trains arriving and departing daily by 1880, pollution was becoming a crisis. Beyond air quality, steam trains struggled with efficiency. They were slow to accelerate, required frequent maintenance, and operated poorly in environments with frequent stops, such as urban transit lines. Safety concerns added to the issues. Tunnels, which were essential in cities, became hazardous with thick smoke reducing visibility and making ventilation a constant problem. The answer to these challenges lay in electrification. In 1879, Werner von Siemens showcased the world's first electric railway in Berlin. While it was a modest project, it demonstrated the potential of electricity for rail transport. Engineers began exploring how electric power could address the inefficiencies of steam. One of the earliest success stories came in the United States. The Baltimore Belt Line, completed in 1895, was among the first major railways to use electrification. Designed to eliminate the smoke and noise of steam trains in Baltimore's tunnels, it was a critical proof of concept for electric trains in urban settings. The rise of electrification coincided with a period of rapid urbanization. Cities around the world were expanding, and transportation systems needed to keep up. Steam trains were too slow and cumbersome to support this growth. Electrification allowed railways to become more efficient and adaptable. In London, the Metropolitan Railway, which became part of the London Underground, began electrifying its lines in 1901. This move was essential for addressing the city's transportation challenges. By eliminating the pollution and inefficiencies of steam, electric trains allowed underground rail systems to thrive. Electrification also enabled the expansion of suburban areas. In Chicago, for example, electric railways helped grow the city's metropolitan region by over 50% by 1920. People could now live farther from the city center while still enjoying a reliable commute. This shift laid the groundwork for modern suburban lifestyle. The transition to electric trains was driven by remarkable technological advancements. Among the most important was the invention of the third rail system by Frank J. Sprague in 1887. This system provided a continuous power supply to trains without the need for overhead wires, making it ideal for urban transit networks. Another milestone was the electrification of New York's Grand Central Terminal in 1913. The use of third rail technology there eliminated steam locomotives from the city center, drastically improving air quality and operational efficiency. Grand Central became a symbol of how electrification could revolutionize major rail hubs. Electrification was not without its challenges. Building the necessary infrastructure, including power stations, substations, and specialized tracks, required significant investment. Electrifying the New York Central Railroad in the early 1900s, for instance, cost over $35 million, equivalent to nearly $1 billion today. There was also resistance from vested interests. The coal industry and manufacturers of steam locomotives opposed electrification, fearing the loss of a lucrative market. Railway companies were hesitant to invest in unproven technologies. Engineers faced technical hurdles as well, such as designing systems that could maintain consistent power over long distances. Despite these obstacles, the benefits of electrification ultimately outweighed the costs. Electrification transformed rail travel for passengers. Electric trains were faster, quieter, and more reliable than their steam-powered predecessors. Urban commuter trains, for example, doubled their average speed, from 15 miles per hour with steam to over 30 miles per hour with electric engines. Punctuality improved significantly, as electric trains were less prone to mechanical failures. Noise pollution was also drastically reduced. While steam trains were notorious for their deafening whistles and engine noise, electric trains operated almost silently, making them more pleasant for passengers and urban residents alike. These improvements encouraged more people to use trains, boosting ridership and making public transit an integral part of city life. The economic benefits of electrification were immense. Faster and more reliable trains improved the movement of goods and people, stimulating local economies. In industrial cities, electrified railways enabled workers to commute more efficiently, expanding access to job opportunities. For example, in Tokyo, the introduction of electric train lines in the early 20th century fueled the city's rapid economic growth. Electrification also had a democratizing effect. By reducing operating costs, railways could offer lower fares, making public transit accessible to a wider range of people. This helped bridge socio-economic divides, allowing individuals from different backgrounds to share the same transportation systems. The shift to electrified railways coincided with the rise of suburbanization, as people moved away from crowded city centers. However, by the mid-20th century, trains faced competition from automobiles. In cities like New York, public transit dominated until the 1950s, when cars became more affordable and highways expanded. Despite this competition, electrified trains remained critical in densely populated areas. In 1920, over 80% of trips in New York City were made using public transportation. Even today, in cities like Tokyo and Paris, electrified rail systems are the backbone of urban mobility. The electrification of railways paved the way for modern transportation systems. Unlike steam and diesel engines, electric trains produce significantly fewer greenhouse gas emissions, making them a cornerstone of sustainable transit. In cities like Copenhagen, entire rail networks now run on renewable energy. Electrification also enabled the development of high-speed rail. The launch of Japan's Shinkansen in 1964 showed how electrified trains could compete with cars and airplanes for long-distance travel. Today, countries around the world are investing in electrified rail systems to reduce emissions and improve connectivity. The electrification of trains was more than a technological innovation, it was a defining chapter in transportation history. By addressing the challenges of steam locomotives, electrification improved efficiency, reduced pollution, and reshaped urban mobility.